let's learn lesson 5, solving polynomial equations. First of all, let's have a look at today's learning goals. After this lesson, you will be able to interpret the meaning of the roots of polynomial equation, zeros of the corresponding polynomial function, and the x-intercepts of the related graph of the polynomial function. Then you will be able to solve polynomial equations using factoring or technology. And also, you will be able to solve real-world problems that involve polynomial equations. Okay, so first of all, let's have a look at the interpretation of polynomial equations. And then after that, we'll be looking at how to solve a polynomial equations, and then how to solve a real-world problem involving polynomial equations. Okay, so first of all, let's have a look at how do we interpret polynomial equations. So suppose px is a polynomial function, then px b0 is a polynomial equation. The real roots of the polynomial equation px being 0 correspond to zeros of the polynomial function px, and also correspond to the x-coordinates of the x-intercepts of the graph of px. So these are the meanings of the real roots of px, which is correspondent to zeros, or the x-coordinates of the x-intercepts of the graph of px. So for example, if px is x squared minus x minus 2, if this is a polynomial function, then px be 0, which is x squared minus x minus 2 is 0, is a polynomial equation, right? And note that x being minus 1 or 2 are two roots of x squared minus x minus 2 being 0. Then x being minus 1 and x being minus 2 are two zeros of px, right? So the two roots are actually two zeros in the polynomial function. And minus 1, 0, and 2, 0 are the two x-intercepts of the graph of px, as you can see from the graph shown on the right. So two roots are actually two zeros, which are actually two x-intercepts. Understand? Okay, so now let's have a look at how do we solve polynomial equations. There are two types of polynomial functions. One is if a polynomial function px is factorable, we can then solve the corresponding polynomial equation px equals 0 by factoring, right? And otherwise, we can solve it using technology, either a calculator or some online tools. Okay, so now let's have a look at an example. So this is an example of factorable polynomial. Solve x cubed minus x squared minus 2x. Okay, so first of all, in order to solve this equation, we need to factor the polynomial on the left, right? First of all, we can put the greatest common factor in front, which is x. And what's left is x squared minus x minus 2, right? And this is 0. And x squared minus x minus 2, according to the cross product method, we can easily factor it into x minus 2 and x plus 1, right? And now we have a product of three terms being 0. That means the solution is x being 0, or x minus 2 being 0, or x plus 1 being 0. So the final solution is x being 0, or x being 2, or x being minus 1, right? So for a factorable polynomial, the key is to factor the polynomial expression, right? Okay, next, let's see an example of non-factorable polynomial. So now we have a function, we have an equation like this. So as you can see, if we put it in a standard form, x cubed minus 3x plus 1 be 0. This is actually not very easy to factor, right? Actually, it's not factorable. So for a polynomial equation like this, we can use a calculator to solve the equation, right? I'm not gonna show you how to use a calculator to solve this. You need to check the menu of your calculator, okay? Or we can use some online tools to solve this equation as well. For example, one of the typical tools is called Wolfram Alpha. I'll show you here. Okay, you can just go to the website here and input your equation here. We have x cubed minus 3x plus 1 is 0. Okay, so now let's give it a try. You can just put solve x squared minus 3x plus 1 equals 0. And hit enter or click this equality sign here. And this online tool will automatically calculate the solution for you, okay? This is a analytical solution. If you want approximate forms, just click the approximate forms here, and then it will calculate some approximate values for you. These are all possible solutions for this function, for this equation. Understand? Okay, we're not gonna talk about too much here. You can check that online from this website, okay? All right, so next, let's make some practice. First of all, solve by factoring the following equation. I'll give you 2 minutes to think about that. Okay, any thoughts here? Okay, so solve by factoring, we are trying to factor the left-hand side, right? In order to solve this equation, we need to factor the expressions on the left. So note here the ratio between the two terms is 3, right? And the ratio between the last two terms seems also be 3. So we can try factoring by grouping, right? Okay, so this is equivalent to if we group the first two terms and then the last two terms, we can get the function like this: x squared times 3x plus 1 minus, we can put a 4. 4 is a common factor of the last two terms, right? Then 3x plus 1 equals 0. And this is equivalent to, and now 3x plus 1 is a common factor, right? We can put it in front, and x squared minus 4 equals 0. And note that x squared minus 4 is also factorable to x plus 2, x minus 2 equals 0, right? So the solution of this function is xb minus 1/3 or xb minus 2 or xb positive 2, right? So as you can see here, the reason why we learn factoring first is that this is a very useful technique to solve a equation like this, right? Okay, next. Solve by factoring the following equations: x cubed minus 4x squared minus 45x equals 0. Okay, I'll give you 2 minutes to think about that, okay? Okay, let's have a look at the solutions. All right, again, the key to solve this equation is to factor the expression on the left first, right? So first of all, by observation, we can see that we can first factor out the greatest common factor, which is x, right? And what's left behind is x squared minus 4x minus 45, right? And then we can factor this quadratic equation using the cross product. So xx, you can put a -9 and 5 here. So -9x plus 5x is -4x, which is exactly the term in the middle. So this is equivalent to x times x minus 9 times x plus 5 equals 0. And then you can see that zeros are x is 0, or x is 9, or x is -5. There are 3 solutions, right? Okay. Next, let's have a look at this question. Solve by factoring x cubed minus 4x squared minus 3x plus 18 equals 0. I'll give you 3 minutes to think about this question. Okay, have you finished? So by first glance, it may not be very easy to factor this expression on the left-hand side, right? So we can try using the factor theorem together with the integral zero theorem, right? We want to find a factor x minus b, which is a factor of this expression, right? And according to the theorem, we know that if x minus b is a factor, then b must be a factor of the coefficient, right? So first of all, we need to find the factors of all possible factors of the coefficient 18, right? And we only need to check all the factors of 18 to see if that value can make the expression on the left be 0, right? So first of all, factors of 18 are positive or negative 1 or 2 or 3 or 6 or 9 or 18, right? And then if we let px be the expression on the left, and then we can just check p positive or negative 1 or positive or negative 2 or etc., right? So we need to check. So first of all, let's start from the easiest number, which is 1. So P1 is 1 minus 4 minus 3 plus 18, which is not 0, right? And let's check P minus 1. Minus 1 minus 4 minus 3 plus 18, which is not 0 either. Okay, let's check these numbers one by one. And as you check, you can see that when you put a 3 in px, it's actually 27 minus 36 minus 9 plus 18, which is 0, right? So now we have found a factor, which is x minus 3. So x minus 3 is a factor. So what's the other factor? The other factor can be found by using the long division, right? Okay, divided by x minus 3. First, we can put x squared here. Okay, so let's call this asterisk. So asterisk is equivalent to x minus 3. The other factor is x squared minus x minus 6 equals 0, right? And apparently the later part can be further factored to x minus 3, x plus 2, right? Okay, so now you can see one of the solution is x equals 3. The other solution is x equals minus 2, right? This is our final solution. All right, please have a look at this. Any questions, let me know. All right, analyze the writing of the solution is illustrated in this slide. You can check this after the class, okay? All right, let's have a look at another practice. Solve by factoring. 2x cubed plus 3x squared minus 5x minus 6 is 0. Okay, I'll give you 3 minutes to think about it. Okay, let's have a look at the solutions. So this time we have, again, a very long expression, right? It seems that it's not very easy to factor. For a very long expression, you can try using factoring by grouping or by using the factor theorem along with integral zero theorem or the rational zero theorem, right? So this time, let's try using the factoring by grouping technique. So note the ratio between these two numbers is 2 to 3, and these two numbers is 5 to 6. So we cannot directly grouping by we cannot directly group the first two terms and then the last two terms, right? That might not work. But note here, these two numbers are very close. 2 and 3 are very close, and 5 and 6 are very close. So probably we can try split the 3x squared to a 2x squared, and then plus another x squared. Then you can see here, the common factor might be x plus 1, right? So in order to have x plus 1 be the common factor, then you will have another x here to group with x squared in front, right? So if you have a plus x here, note here, in the original expression, this is minus 5x, right? So you need to put a minus 6x here and then minus 6, right? So if you group these two terms, and these two terms, and x plus 1 might be the common factor, right? So let's have a try. The original equation is equivalent to 2x cubed plus 2x squared plus x squared plus x minus 6x minus 6, right? And then we group the terms like this. And this is equivalent to first two terms, common factor is x squared, and what's left there is, 2x squared, x plus 1, right? And next two terms, if we put x in front, you will get another x plus 1. And last two terms, if we put 6 in front, and we'll have another x plus 1, right? So next step, apparently x plus 1 is the common factor, which can be put in front. And what's left behind is 2x squared plus x minus 6, right? And then let's check if this one here can be factored further. So 2x squared can be split into x and 2x. And minus 6 can be factored to minus 2 and 3, right? But in order to have a positive x, we need to make this number positive and this number here negative. In this way, by cross product, you will get 4x minus 3x, which is x, which is exactly the term in the middle, right? So this is equivalent to x plus 1, x plus 2 times 2x minus 3 equals 0. So the solutions are x equals 1, or x equals minus 2, or x equals 3 over 2, right? Okay, please have a look at this. Any questions? Okay, if you don't have any questions, let's have a look at the next one. Solve by factoring x cubed minus 5x squared plus 8 equals minus 2x. Okay, I'll give you 3 minutes to think about this. All right, let's have a look at the solutions. So first of all, let's rewrite the equation in the standard form. X cubed minus 5x squared plus 2x plus 8 equals 0, right? And we want to factor the expressions on the left. Okay, again, we can use a factor theorem, right? So note that let's let me use a notation. Fx equals the expression on the left. And note that f1 is, sorry, f minus 1. If we put f minus 1, we will get minus 1 minus 5 plus 2 plus sorry, not plus 2, should be minus 2, right? Minus 1 minus 5 minus 2 plus 8, which is 0, right? And that means x plus 1 is a factor, right? Okay, so now we can find the other factor using the long division. Okay, so as you can see here, the other factor is x squared minus 6x plus 8, right? Okay, so let's call this asterisk. The equation asterisk is equivalent to x plus 1 times x squared minus 6x plus 8 equals 0, right? And of course, the later part can be further factored to x minus 2, x minus 4, right? And then the solutions are x equals minus 1, or x equals 2, or x equals 4, right? Okay, any questions? Okay, if you don't have any questions, let's have a look at the next question. Solve by factoring. 2x cubed plus 3x squared minus 11x minus 6 equals 0. Hey, I'll give you 3 minutes to think about it. All right, have you finished? Okay, again, the key to solve this equation is to factor the expression on the left-hand side, right? So this time it may not be very easy to factor this by grouping. So we can try using the factor theorem along with the rational zero theorem, right? Remember, you can always use the factor theorem if you feel difficult to factor any expression. Okay, so let's use a denotation fx to stand for the expression on the left-hand side. And according to the rational zero theorem, we need to find a ratio b over a, which can make fx be 0, right? If f b over a is 0, b must be a factor of the constant term, and a must be a factor of the leading coefficient, right? So let's check all the possible values of b. So let b be the factors of -6, which is minus or +1 or 2 or 3 or 6. And let a be all the possible values of the factor of the leading coefficient, which is positive or -1 or positive or -2. Okay, so possible values of b over a is positive or -1 or 2 or 3 or 6, right? And then 1/2 3 over 2 . So you need to check these values to see if any of them can make fx be 0, right? So let's usually check from the easiest value. So f1 is 2 plus 3 minus 11 minus 6, which is below 0, right? So probably 1 is too small. So let's check f2. f2 is 2 times 8 plus 12 minus 22 minus 6, right? So this is 28 minus 28, which is 0, right? So f2 is 0, that means x minus 2 is a factor of fx, right? And then we can find the other factor using the long division. Okay, so as you can see here, the other factor is 2x squared plus 7x plus 3. So let's call the original equation is asteristic. So asteristic is equivalent to x minus 2 times 2x squared plus 7x plus 3 equals 0, right? And let's see if this can be factored further. So x squared can be factored to x times 2x. And 3 can be factored to 3 by 1. And by cross product, 6x plus x is 7x, which is a term in the middle, right? Okay, so this factor can be further factored to x plus 3 times 2x plus 1, right? Okay, so now you can see that the solutions are x equals 2, or x equals -3, or x equals -1/2. Okay, please have a look at this. Any questions? If you don't have any questions, you can also check the solutions in this slide. Okay, this is a more formal way to write your solution. All right, next, let's have a look at an example of solving real-world problems involving polynomial equations. Okay, so this time, suppose the volume V in cubic centimeters of a block of an ice that the sculptor uses to carve the wings of a dragon can be modeled by this function. Vx is 9x cubed plus 60x squared plus 249x, where x represents the thickness of the block in centimeters. So the question is, what maximum thickness of wings can be carved from a block of ice with volume 2532? Okay, so basically in order to solve this real world problem, first step is to model the problem, which is stated in natural language, into mathematical language, right? All right, so let's have a look at the solutions together. First of all, determine the problem is actually asking you to determine the value of x that satisfy Vx equals 2532, right? So we can just let Vx, which is 9x cubed plus 60x squared plus 249x equals 2532, right? And our task is just to solve this equation, right? So the original problem has been transferred to actually solving this equation now, right? Okay, now let's rewrite the equation in a standard form. And as you can see here, first step, 3 is a greatest common factor, so we can put 3 in front. And then you can divide both sides using a 3. So after simplification, the equation becomes this one, right? And then in order to solve it, usually we'll need to factor the expressions on the left, which may seem not very easy, right? So again, you can always refer to the factor theorem along with the rational zero theorem. So note that we need to check b over a, right? To see if it's a value that can make the expression on the left be 0. So b is a factor of the constant, and a is a factor of the leading coefficient. So we need to check all the possible values of b, and then all the possible values of a, and then all the possible values of b over a, which are these values. So basically, you need to check if any of these values can make the expression on the left-hand side be 0, right? So luckily, when you check 4, you can find that 4 can make the expression on the left-hand side be 0. So that means x minus 4 must be a factor. As long as you got one factor, you can find the other using the long division, right? And by using the long division, we can find the other factor is 3x squared plus 32 plus 211, right? And then the original equation is equivalent to this one. So that's equivalent to either x minus 4 be 0 or the later part be 0, right? So if x minus 4 be 0, that means x being 4, right? Okay, the later part. This is actually a quadratic equation, which you have already learned how to solve, right? Well, usually we can either solve it by completing the square using existing formulas or by using the determinant, right? So let's check the determinant first. Determinant is b squared, which is 32 squared minus 4ac, right? So 4 by 3 by 211. So 32 squared is 1024 minus 2532, which is apparently smaller than 0. So that means this equation has no roots, right? I mean, has no roots in the real number set. Because this is a real world problem. So x here has a meaning. X is the thickness of an ice, the thickness of the block, right? So it cannot be a non-real number. So x equals 4 is our final solution. That means the thickness of the wings is 4 centimeters. Understand? Okay. Now let's do a practice. This time I'll give you 3 minutes to think about this question by yourself, okay? All right, have you finished? Okay, so the width of a square-based storage tank is 3 meters less than its height. The tank has a capacity of 20 square meters. If the dimensions are integer values in meters, what are they? Okay, so we can sketch a graph of this problem. Square-based tank, right? So suppose the height is h, and w is the width. Okay, let h be the height and w be the width. The unit are centimeters for both, right? So the volume is w squared times h, right? And we also know that the width is 3 meters less than its height. So that is equivalent to h minus 3 squared times h, right? And we also know that the capacity is 20, or this should be cubic meters. There's a typo, sorry. This should be a 20. So the problem is that we know this information and solve for the value of h, right? Okay, so let's call this asterisk. So equation asterisk is equivalent to, let's expand the expression here, h squared minus 6h plus 9 times h minus 20 be 0, right? So that's h cubed minus 6h squared plus 9h minus 20 equals 0, right? Okay, so at first glance, it may not be very easy to factor this. So again, we can refer to the factor theorem along with the integral zero theorem, right? So first of all, let B equals all possible factors of minus 20, which is positive or minus, positive or negative 1, or 2, or 4, or 5, or 10, or 20, right? We need to check these values one by one to see if any values that can make the expression on the left-hand side be 0, right? So note here, when B is 5, 5 cubed minus 6 times 5 square plus 9 by 5 minus 20 is actually 125 minus 130 plus 45 minus 20. Sorry, this should be 150, not 140. So if we check these numbers, this is 0, right? So that means b minus 5 must be one factor. So in order to find the other factor, we need to perform a long division, right? Okay, so the other factor is h squared minus h plus 4. Okay, so that means h minus 5 times h squared minus h plus 4 equals 0, right? So that means h is 5, or h squared plus minus h plus 4 is 0, right? So this is a quadratic equation. Let's check the determinant first. Determinant is 1 minus 4 by 1 by 4, which is smaller than 0, so there is no real solution for this equation, right? So the final solution is 5 equals, h equals 5 meters. Sorry, the unit should be meters, not centimeters. Final solution would be h equals 5 meters, right? Okay, then the width is 3 meters less, so width is 2 meters, right? So the dimensions is height equals 5 meters and width equals 2 meters, right? Okay, please have a look at this question. Any problems? Okay, and you can also check a nice writing of the final solutions in this slide after the class, okay? All right, let's make a summary to today's class. Okay, after today's lesson, now you should be able to interpret the meaning of the roots of a polynomial equation, the zeros of the corresponding polynomial function, and x-intercepts of the related graph of the polynomial function. Actually, these concepts are equivalent, right? Second, now you should be able to solve polynomial equations using factoring or technology. And you should also be able to solve real-world problems that involve polynomial equations, okay? For real-world problems, usually you need to convert the problem stated in natural language into a mathematical model and solve for that model to get you the final solution, right? Okay, so these are the key concepts we have learned for today.